Yeah, hi candidates. This side Ankit, and I hope I'm audible to everyone. Kindly just confirm me this once again. Let me just share my screen as well. Okay. So, hello, Sarath, Rakesh, uh, Santhala, and the rest candidates. Guys, I hope I'm audible, right? Let me know. Let me know in the message box. I have already shared my screen. Hello, Preeti, Taruna, Hema, and other candidates. Guys, I'm audible. Class, just let me know quickly. Do it fast. Just right. Okay, very good, right? So I hope everyone is aware that we have already completed multiple models, right? Linear regression, logistic regression, followed by the knife-based model, and then the decision tree model, right? In the yesterday class, we just completed the mathematical intuition behind the decision tree model, and all of you were already aware that how to particularly calculate the Gini index, right? I hope everyone has seen that particular video, right? So let me just open that same notebook, and the model that we were particularly performing is the decision tree model. Okay, let me just give you the quickly recap of what exactly the decision tree was, and we have to just start with the practical implementation. Okay, so we know that in the decision tree model, it's a complete supervised machine learning model where we can use it for both regression problem and the classification one, right? And we just took this data. It was like the play tennis data set, where we have the four features: outlook, temperature, humidity, and the windy, and the way whether the player will play the tennis or not. The data is completely based on that, right? Let me just click on this connect, and you guys can take a reference of this notebook. Let me just share this notebook with you, and so that you can do the practice parallelly, right? Okay, so class, I have already shared my GitHub link with all of you, right? If you want the overall code notebook of whatever that we have completed so far, so you can take a reference of that GitHub link as well, right? Okay, so in the decision tree model, we generally know that we have to identify the root node, and then followed by the decision node, and the final one where we are getting the answer is called the leaf node or the terminal node, right? We took reference example from the Medium article link, where we generally perform this kind of decision tree approach based on the play tennis dataset, right? And some of you also know that this decision tree, we generally call this as a cart algorithm. The cart is like classification and the regression tree, and inside this decision tree, the mathematical intuition is we have to calculate the Gini index, and the Gini index just simply check or calculate the level of impurity of a given features. The more the impurity, the less it will be selected as a root node. So what we have to do, we have to just minimize, or we have to select those features which are having less or very low, or very low number of the overall Gini value and the low value of impurity, right? We will generally select those as a root node, right? So the interviewer will generally ask this question: how to identify the root node with the help of some sort of entropy equation we have, and we can use the Gini index as well, right? Now we know that we just taken an example of this one, like the play tennis data set, right? So let's just do one thing. Let's start to do this practically, how to create the ML model using the decision tree, and we'll just simply pick the data set of the same, which is play tennis data set, right? So let this implement the same thing practically, right? So we know that everything was already, you are already aware with that. The step one is all about load important module, right? So what I do, let me just quickly import all the modules. Import pandas as 3D, import matplotlib. If you want to do this practically, guys, you can use the same reference node. Okay, import c1 as SNS, and import numpy as np. You have to import OS as well with some sort of import warnings. And we know that inside the warnings, we generally need to write this as a filter warning, and we can simply ignore the whatever future warnings that we are getting in the some sort of version mismatch, so we can ignore those one, right? IGNORE. Perfect. Now let me just simply write this done. Right now we are not importing any sklearn module, right? We'll import the sklearn module once we understand how to precisely load the data, right? So the data set is completely play tennis dataset. So you can just go to Google and write down play tennis dataset. You will get the article or like the URL link of play tennis dataset. You can take this URL, just go to this download and make sure the URL something like this, Federico, and go to this download option. We'll get the copy of this, get like the Kaggle code, right? So just go to step 2, and the step 2 is to load your data set, right? So you can just write down this thing, load data set. So we are just performing the practical concept candidate. We already know how to understand the decision tree regression part and the classification part. We know that the decision tree generally prefer the entropy concept or like the Gini index or like the impurity concept, right? But we need to understand now how to build a model if we are getting some sort of like any plate, any kind of data set or any kind of other data set, right? So step 2 is to load data set. Just simply run this code, import Kaggle Hub. Kaggle Hub generally gives you the hub of data set where you can simply give the path or like the URL, and this will download the data set, right? Now, since we have loaded this data set now, so we have to use the OS module. OS module gives you this list dir. You just need to pass this path object. The path object generally gives you the file name, right? Because this is in a list format now. So let me just quickly call out this file name, and let's just store this file name inside the file name, right? Now I need to build the file path, right? So the file path is just nothing. The previous path. The previous path is something like this: Kaggle input slash play tennis. So what I'll do, I'll just simply call the previous path, then followed by some string concatenation approach, and then you can simply add your file name. Once you do this, if you just run your file path like this one, you will get the final file path, right? Now you want to read out this data set. Since we know that the data set like ends with .csv, so we have to use this read underscore CSV, right? Just simply give the file path, and you have loaded your data set successfully. Now what you can do, instead of direct writing this as df, let me just write this as tennis df, and tennis df dot sample. This is the sample data set that we are getting, right? Let me just rename it quickly. Perfect candidate. I hope everyone is getting my point, right? Okay. Now the problem with this data set now, in the previous or like the last class, we just generally perform the right in the play tennis data set. We are having only 4 features: outlook, temperature, humidity, and wind criteria. And the final output one is the play tennis. But if we are loading this data set using Kaggle, now we are getting one additional feature that is called day. But the problem is this day is just for like some sort of extra information. Right now, there is no requirement of this type of column, right? So what I'll do, I'll just simply drop this column. And we know that we generally refer this as a kind of pre-processing. This generally is called the data pre-processing, right? We are preparing our data for ML model building, right? For ML model. So you can just write this data pre-processing for ML model, and you can just simply say, instead of calling this complete tennis df, let's just remove this column. Guys, everyone, I hope you know that how to drop a column using the like pandas data frame approach. Let me just know the answer, right? How to drop this column? Anyone does any specific idea how to particularly drop this column, guys? Write down in the message box. Candidates, all candidates, right now we have more than 20 plus candidates connected. How to drop the particular column, right? You just need to not to understand only the coding part. You have to just quickly understand how to perform with like how to perform different operations on different requirements, right? If you want to drop this column now, we have this method that is called drop method, right? So you can just simply call this tennis df dot drop, and you have to quickly give your the column name right now, because we are only dropping the one column now. So let me just write this quickly. And this column generally try to find out in a row level. So we have to give the column value. It's like axis is equals to 1. Once you run this now, you will get your updated data set. It's like outlook, temperature, humidity, wind, and play. Now let me just quickly store this inside the actual data frame. And this is the sample data set, right? Okay. Now, is there any problem with this data set, guys? If I want to quickly build ML model, what is the problem with this data set? Just let me know in the message box, candidate, everyone. Preksha, Sarath, Rakesh, Santla, and the rest candidates, 20 others. What is the problem with this data set, right? We know that we can perform some sort of EDA, but just let me know the problem with this data set. Right now, we are getting the features. outlook, temperature, humidity, wind, and play. And we know that by using the Gini index or like the entropy concept, the outlook will going to be the root node, right? But the problem with this data set, can anyone let me know what is the problem with this data set? Candidate Apeksha, Sarath, Rakesh. Interview can ask you this type of question, right? So the problem with this data set is now we have all data set in textual nature, right? All data set in textual data type. And we know that ML not only ML cannot work with the textual data type. We have to convert this textual data type into the numerical one. Now, how to do this? There is a technique. That technique is called feature engineering. We have already performed this, right? FEATURE, feature engineering. And where in this, we just simply convert the textual data to the numerical one. I hope everyone understands this concept, right? What is feature engineering, right? Where we can simply convert the textual data into the numerical one. Now, let's just understand one thing. Since we can use the feature engineering, we can easily convert the textual data into the numerical one. But what about the exploratory data analysis part? Everyone, you know that we have to perform some sort of EDA, right? But if we are performing EDA on each and every class, the 50% of class generally ends up with performing EDA only. So what I'll do, I'll just do some basic operation of EDA apart from df.shape, df.tail, head, fetching, described, and so on, right? I'll completely ignoring all that one. I hope everyone is comfortable with that, right? Okay, so let me just quickly pick this data set. And we know that this data set is like 4 different features, and the final one is the target one. So what I'll do, I'll just simply call this as X, and let me just convert this or like slice this data set. So I'll just use the iLook approach where I'm considering all the rows and I'm eliminating the last one because last one is for the Y value. So let me just write this as -1 index up to the -1 index, not only the -1. And if you just run this, you'll get the only X features, right? This is your X. Now let's just do with this Y also. df.iLock, you want all the rows, so you can just write this as column. And because you only want the last column, na, so you are just approaching the -1. The -1 column, we generally try to pick the last column. It's like the play yes or play no. Now we have converted into data into X and Y format, right? We have split data into the X and Y format. Now let's just perform some EDA part. So I'll just simply running the for loop over the I for I in X. If I am directly running the for loop over the I or like any of the data frame, it try to pick the columns, right? So you can just say, show me the value of I. We know that in the X data set, we are having the 4 features now. That is the reason we are getting 4 different sort of features, right? Now, let's just do one thing. Instead of calling all the I, we want to quickly analyze the data set, right? So let's just perform the value counts analysis. So it is like simply go to this X data frame, call this column. The first column is like the outlook, and you can just quickly call this value counts. And we know that inside the value counts, it try to group the data and let you know what exactly different types of frequencies that we are getting, right? And let's just write this additional margin gap to understand different sort of analysis and quickly do this as a string like frequency analysis for I column. And we know that I is just nothing, the first column or followed by the rest column, right? So you are getting something like this, frequency analysis for outlook. And in that particular data set candidate, we are getting 5 rows for the sunny, 5 rows for the rain, and 4 rows for the overcast, then followed by the temperature. We are having 3 set of temperature. First is mild, second is hot, and third one is cool with their corresponding data set 644, right? Same as it is with the humidity. We are only getting the high normal humidity and then followed by the 50% of the data set, right? And then the last one is the wind data set where we are getting weak records number of 8 times and is strong as 6 times, right? So it's like the frequency analysis of your overall features, right? We are performing this, right? Now let's just do one thing, quickly understand the unique values inside all this. Although we know that wind has only weak and strong, right? So let's just do this with the help of this. Instead of value count, you can use the unique value, UNIQUE. The unique will try to give you the unique values only, right? And you can just say right here, some sort of like this. Instead of this frequency analysis, you can just say unique unique value in column I. Unique value in column I is some sort of like this. It will try to give you the unique values. It's like unique value in the column outlook, or instead of a column, you can just say feature outlook, and you can just get the value. We are only having the three different features inside the feature outlook. The first one is sunny, overcast, and the rain. Same followed by the temperature. It's like hot, mild, and cold. And then humidity, and the final one is the wind, right? So in this, with the help of for loop candidate, you can do some basic EDA operation, right? Now let's just quickly understand the visualization part of the EDA. Okay, so for that, what I'll do, I'll just simply call this data. Okay, and we know that whenever we are writing this value count, now this value count gives you the two set of data set. The first one is called the index, and second one is called the value, right? So what we can do, we can simply convert this data set. Instead of printing this, let me just quickly call the data set. It's like value at value at x, value at x, and value at y, value at y. We just want to like create a visual na? So instead of calling this print method or like print function, we are converting this value count data into two parts. If we are creating a, suppose we are creating the bar chart na, so we are just calling the index at the value of x level at like row level, and same with values as the value of y level, right? And now you can quickly turn out this x and y value with the help of bar graph, and you can just say you have to plot the value of x and then followed by the value of y. Now it can simply turn this data value count into the meaningful analysis. And if you want to do some color coding as well, let me just use the dynamic color coding. So you can just use the SNS.color palette, and inside the color palette, you can give your different set of palette color, right? RAINBOW, rainbow you can use, right? We have different set of palettes. You can use rainbow, you can use magma, you can use cool, and you can use Mako, and then followed by etc. Right? These are the set of color palette that you can use, right? If you just want to show this graph, you can just show this, right? PLT.show. Now you are getting the different visual analysis, right? Let's just quickly turn this into the meaningful one. So what I'm doing, I'm just simply storing this data inside Access. And if I want to turn out the values now, you can just simply go to this plt.bar label and just give the value as Access, right? Now let's just give the plt.title as well, to that particularly give you the what kind of analysis this is, right? So plt.title, and inside this title you can just say the bar graph for I. And we know that bar graph for I is like the first I outlook now. It will give you the data set like this. Bar graph for wind, or instead of bar graph, you can say distribution analysis for like this, right? Frequency graph for this. Instead of bar graph, now let's just turn this to, well, this is a bar graph, but we are just considering this as a frequency bar graph for I, right? It's like frequency graph for wind. We are getting 8 data as the weak one and 6 data with the strong one, right? Okay, so in this way, we can simply turn out this value. And let me just check, is there any option for the width as well, right? We can pass the width with the value of 0 to 1. Yes, we are getting the width values as well, right? Now let's just quickly give the value of x and y as well. So we know that the plt dot x label is like the x-axis, and we can just simply give the inside the f string the value of I, and we know that each I represented by the corresponding column name, right? And then for the y label, we can give the count, right? Because we are simply counting the counts value, right? So we are getting some sort of data like this. The problem with the label, let me just quickly turn out this. Matplotlib pyplot has no attribute x label. Why we're not getting the x label? Okay, the problem with this L, right? Now we are getting the values like this one is the x label, this one is x label for the humidity, this one is x label for the wind as well, right? So guys, you have quickly turn out this overall visuals, like overall data set into this kind of visual, right? That is called your overall EDA part, right? Now you know that you can just get the pair plot as well. You can get some sort of like the correlation chart as well, right? But these are the part of the EDA. Now this we have to turn out this into the meaningful ML model, right? I hope everyone is getting my point, guys. Just let me know, are you getting my point, guys? Whatever I'm saying, everyone, all the candidates, right? Now let's just do one thing. Since we have already analyzed this data set with the help of some sort of visualization, now let's just try to build the model. But before building the model, we know that the data set is completely, it's like textual in nature. Now we have to convert this into the numerical one. And we know that we can use the one hot encoding technique. I hope everyone is familiar with the one hot encoding. In the previous classes, we have used this technique, right? To just quickly turn out the textual data into the numerical one. Guys, just let me know in the message box or like in the chat area. I hope everyone is aware with the technique that is called one hot encoding or like the pd.getDummies technique, where we can simply convert the textual data into the numerical one. Just let me know if you're aware with that, right? Okay, now let's just import that one. What you can do, you can simply turn out the all textual data into the numerical one. So you have to use this pd.getDummies. Pd.getDummies, what it will do, it will convert the overall column into the numerical one, right? We are getting the numerical values like 0 and 1 or like true and false. So what you can say, you can just say, let's just keep this data type as integer, okay? And now we are keeping the data type as integer. And if you are aware with the pd.getDummies technique, we are getting the values of like the extra additional column. So you can just simply drop the first column and you can just write this argument. It's like drop is equals to true. It will try to drop out the first column. Instead of drop true, you can just write down this as drop first, right? I think the argument is drop first. Yes, the argument is drop first is equals to true. And now we are getting the required column only, right? So guys, we have converted all the data set. Can you just let me know if you're aware with that? pd.getDummies. If you're not aware with that, just let me know. Just do it fast. Just do it fast, candidate. Peksha, Sarath. How many of you have seen this technique like pd.getDummies? If you're not aware with that, just let me know. I'll not use this one. I have another approach as well. I can use that one also. Just let me know if you're not aware with that. pd.getDummies. Just write now. Just write no or yes in the message box. If you're not aware with the pd.getDummies technique, I need to explain this, right? Class, just write down fast. Peksha, Sarath, the rest candidates. Quickly do this fast. Okay, I hope everyone is not aware with that, right? So let me just use the another technique, right? Instead of this one, what I'll do, I'll just simply pick my X data frame and let this do the manual mapping. I'll just simply say this sunny as 0, overcast as 1, and rain as 2, right? And inside the feature engineering technique, we have different set of techniques. The first one is called one hot encoding. The second one is like label encoding. Third one is like ordinal encoding. And the fourth one is like the mapping technique. And one hot encoding is somewhat similar to the pd.getDummies technique. Right? Okay. Let me just do the very basic one. If you're not aware with the rest of the technique, I need like one extra class for that, where I'll just simply explain the different set of feature engineering techniques, right? Let's just use this label encoding technique, or you can do this manually as well, right? So what you have to do, just simply write this from Scikit-learn. These are the part of preprocessing, right? From Scikit-learn.preprocessing, import label encoder. Okay, you're getting this label encoder, right? This label encoder try to labelize is the value like 0, 1, 2, 0, 1, 2 for the individual corresponding value, right? Now you have to create an object that is with the name of LE. It's like the label encoder, and that use this class to particularly initialize the object. And with the help of this LE.fit and transform, we have to give a complete data set. It's like X, right? And we are like getting some error. You should be like, why should be 1D array got an array of shape something like this, right? le.c, we are giving this le.fit underscore transform as X. We need to transform the X data set, but again, we are getting some sort of error. Why? Because it generally asks you for the 1D array and we are getting the overall data frame, right? Let me just show this. Suppose I just want to give a label encoding for the outlook only, right? Let me just pick the outlook one. right? Now here you are seeing now we are getting the 0, 1, 2 value for the outlook one, right? So you can do one thing, you can just run the for loop, or you can reinitialize the loop as well, and then quickly turn out all the values with the 0, 1, 2. Now, but the problem with this one, now we somehow we have to understand what exactly value it has given, right? If we are considering this sunny, it considers sunny as 2, right? And what about the overcast? Overcast as like the 0, and the rain is like the 1. Now, if you just understand one thing, if you know the alphabet A, B, C, D, E, F, G, S to Z, right? Let me just use this one, import string, and string dot alpha uppercase. And here you can candidate see that the overcast, the O value is somewhat written here, right? And the R value is somewhat written here, and then followed by the S. Because we are getting O at the first time, or like before the R and S, that is the reason O value initialized as 0. Here you can see that. I hope everyone is getting my point, right? O is initialized as 0 because they generally try to pick the by default sorting order based on the alphabet sorting, right? Here we are getting O as the 0, 1. And since the R is before this S, that is the reason we are getting rain as 1, R as 1, and then followed by the last one, which is sunny as 2. I hope everyone is getting my point. Guys, just let me know in the message area. Candidate, is there any doubt how this label encoder transform this data set into this 0, 1, 2 meaningful value, right? So based on this, they're ascending order of the string or like the alphabets, right? In the same way, you can do this for the temperature as well, humidity as well, and wind as well. If you want to do use the like for loop approach, you can use this, right? But let me just quickly do this as the manual one so that you can understand this, right? What I'm doing, instead of like running the loop, I'm just quickly slicing my outlook values and reassigning the outlook values in sort of 0, 1, 2 format, right? 0, 1, 2 format. I'm just simply reassigning the value. But the problem with that one, now, we just need to understand how it eventually calculated the parameters, right? What exactly the class is. So you can just run this. If you just want to understand now how it particularly decided which one is 0, which one is 1, and which one is 2. So you can use this le.classes attribute to just quickly understand overcast is considered as 0, rain is considered as 1, and then followed by the last one is sunny. And you know that it's by default based on the alphabet sorting algorithm, right? So let me just quickly copy this. And I'll do the same approach with the rest one, right? Guys, if you want to turn use the loop approach, you can do this, right? But why I'm doing this, so that I can just simply understand the different classes for the different one, right? And we have to store each classes as well, right? So here you can just simply call it this as a label encoder. Okay, and let me just write this as outlook classes, outlook classes is equals to this value. Okay, and then the second column is like the temperature. So just quickly change this to temperature. Okay, now copy this one and write this as temperature classes. Well, if you want to run the loop approach, you can use this candidate. I'm again repeating the same thing, right? This one is for the first one, this one is for the second one, and let's just copy this and make it for the third one, and then followed by the fourth one as well, right? Now the fourth one, the third one is the humidity, na? So let's just call the humidity, and then humidity here. Okay, you can do this parallelly as well. The fourth one is wind. Let's just write this as wind, humidity, and the final one is wind, right? Now, if you just run this, you got all the values, right? Outlook classes, temperature classes, humidity classes, and the wind classes. Now just run this to get the index value of all the classes. The first one is like the outlook classes. We are getting overcast, rainy, and sunny, right? Then same as it is with the temperature one, you'll get the 0 and 1 value, like cool is 0, hot is 1, and mild is 2, right? Same with the last one, it's like the temperature one, not the temperature, it's like the humidity. Okay, it's like high is 0 and normal is 1, and the final one is like the bend value, right? So strong is 0 and weak is considered as 1, right? We need to store all the values so that we can simply understand which values are given to which one, because we are getting multiple 0, 1, 2 now. This 0 is not similar to this 0. That is the reason, because this outlook 0 is represented by this overcast value, and this humidity 0 is represented by this value, right? High value, right? Instead of directly calling this, you can just take the reference of this one. Let's just quickly give the string value of this one, same as it is, copy this so that user can easily understand which class belongs to this, right? Like this. See, it's not about the model building, right? It's all about understanding the problem and how you can simply break down the problem into the simpler facts, right? So this one is like the humidity class, and simply again copy this, the wine class, and simply give the wine classes as well, right? Now we are getting different classes and their different corresponding value. Guys, I hope everyone is familiar with this kind of metrics, right? We generally, if we are getting the 0, 1 kind of metrics now, we generally refer this as a sparse matrix, right? It's like a SPARSE, sparse matrix, right? Now we have turned out the X dataset into the numerical dataset. Can you just let me know? Is there any doubt related to this one, guys? Let me know in the message area. All the candidates. Is there any doubt? All candidates. Maheen, Anas, Neha, Pavan, Pragna, Prajwal, Rakesh, Sarath, Tarun, Vibhalakshmi, and the rest candidates. Guys, is there any doubt related to this one? How we have turned out this textual data into the numerical one with the help of some sort of technique that is called label encoder, where we can labeling each textual data with their corresponding value as like the 0, 1, 2, and we know that how it took the 0, 1, 2 value based on their alphabet sort order, right? Now let's just, in the same way, we can turn out the y value. It's like yes and no with the help of uh, like the mapping technique. Okay, instead of using the label encoder now, let's just use this mapping technique. We have already used this mapping technique, so that we are good to go with the two techniques, right? Then in the next class, I'll let you know about the one hot encoding technique and the ordinal encoding technique one, right? So in this y, you can just simply write this map method, and inside this map method, you have to give the dictionary, right? Where the no is represented by the 0 and the 1 or like the yes is represented by the 1. Now you have to run this, and you know that you can simply reassign this code with the same as y, and you just need to remember this thing also. No is considered as 0 and y is considered as 1 as well, right? Now guys, I have quickly turned out this data into the X dataset and the Y dataset. Now we have sample of X as well. It's like in the 0, 1, 2 format, or like in the numerical one, and then followed by the sample of Y as well. Now you know that you have X dataset and Y dataset, so you can simply call the model building approach, and it's like the dividing the data into the training and testing part, right? Divide dataset into train, test, split, right? So let's just quickly import all the modules of train test split, right? From Scikit-learn dot model selection, Scikit-learn dot model selection, you can call out the train test split, right? Now we know that inside the train test split, we just need to give the X and Y, then followed by their random state, right? RANDOM. I'm not getting the random state, right? Random, let me just write this manually. Random state as 42, and then corresponding test size. I'm not even getting the test size as well. Let me just write this as 0.2, right? Now we know that we'll simply get the data set into the 4 different parts. It's like the X train, X test, Y train, and then followed by the Y test, right? If you just run this, you'll get the train test split data set. Now you just need to call the model. Since we are using the decision tree model, right? So guys, you know that the decision tree generally based on the tree architecture. So what we have to do, we just go to the sklearn, and because the problem is related to the binary classification now, so we because the problem is binary classification, right? So we have to call the matrices as well. Right now, let's just import the decision tree model. So you can just run this from sklearn dot tree. You have to write this one tree, and inside this tree you can call your decision tree. And we know that, just look at this candidate. The first thing that we are getting is the decision tree classifier. And the second thing is like the decision tree regressor. Why we are getting the decision tree regressor? Because I have already told you one thing. Decision tree can be used for both regression problem and for the classification problem as well, right? We can use it for the regression and for the classification as well, right? That is the reason, if you want to perform some sort of the classification instead of classification like the regression problem, so you can use the decision tree regressor, right? Okay, let me just quickly build a model where the model is equals to decision tree classifier. Okay, and you know that you just have to pass the fit. Fit is like for the training step. And let me just simply give the training data set X train and followed by the Y train, right? If you just run this, you'll get your model like built successfully. Now you have to predict some values. For that prediction, you have this predict method, and you can just simply give your X test, and you know that it will give you the Y predicted value. And the Y predicted value is some sort of like this. And let's just quickly compare this Y predicted with the original, that is Y test. The Y test values are like, it's like 110. So we are also getting the values are like 110, right? So there is no such differentiation between the Y predicted and the Y test value, right? So you can just simply say the model is good, right? The accuracy that we are getting is the 100% correct, right? Let's just confirm this once again. We have a model, and inside this model, you can just simply write down this score method. And the score method generally asks you for the Y test value and the Y predicted value, right? We can just give this I think the first one is the Y test, and the second one is the Y predicted value. Let me just run this. No, this one is like my mistake. See, that is the reason you cannot learn the things, right? You have to understand the thing. It was like the X test and the Y test, right? X test and the Y test, and we are getting the accuracy and the as the 100%, right? You can just check the training score as well and the testing score. This is all about for the testing score, right? Let's just check the training score as well. So the training score some sort of like this. Instead of X test, you can just call your X train, and same with the Y train as well. And this is like your training score candidate, right? I hope everyone is getting the same answer, right? Why we are getting the 100% training score as well as the testing score? Because the data set is very less. And we are using the decision tree classifier, and it generally works perfectly if you are getting the binary classification or like some sort of multi-classification as well, right? The decision tree is very the popular algorithm because it is the fundamental of the random forest model that we are going to discuss tomorrow, right? So you can just say decision tree can be used for the both regression problem and the classification one, where we generally converted the textual data into the numerical value. We have built the model, and the model is able to predict the values as well, where we simply compare the model with the Y test with the Y pred one, right? And we are getting the testing and the training accuracy at the 100%. Now the problem is, because the data set is very limited, that is the reason it can be due to the overfitting, right? So let's just understand the different, or let's just calculate the different matrices as well. And you know that if we want to calculate the matrices, we have to use the from Scikit-learn dot matrices, and inside the matrices we have different matrices that generally built for the classification problem. You have to call the accuracy score. The accuracy score is similar to the testing score. You can just simply call the precision score, right? Instead of calling each score individually, guys, you all are aware with all these scores, right? We already took one class to explain you all this kind of scores based on the classification problem, and it was based on the logistic one, I think, right? So instead of calling each score individually, you can call the classification report, and we know that each report or like each score is completely based upon the confusion matrix. So you can just simply call the confusion matrix, right? Let me just run this, and let's just first build the confusion matrix. The confusion matrix generally asks you for the Y test data set and then followed by the Y pred data set. Because we are getting the three values at the diagonal is like true negative and the true positive, and since there are no false positive value and the negative value, that is the reason the accuracy score that we are getting is very high, or like the 100%, right? So you can just simply call your precision score. We will get the precision score as high, right? You can just simply copy this Y test and Y pred to predict the or to calculate the precision score. Same, you can just copy this one And we know that the accuracy score somewhat similar to the model score. So you can just copy this accuracy, we'll get the accuracy score as 100 or like the one, it's like the 100%. You can call the recall score as well, right? And instead of calling each score individually, na, what you can simply do, you can just simply calculate the classification metrics, right? Or like the classification report, and it also pick the same y test and y pred. And since the data set is very limited and the model is very good, that is the reason we are getting the each value score, precision, recall, F1 score, and everything as like the 100% candidate, right? Now we have built the model as well. We have successfully tested the model. We have divided the data set, right? We have checked the model scores as well. Now, how to simply create a function where the customer, where the user will simply give the values, and that values can be converted in numerical one, and that numerical value generally we treat it as the model value, right? Now, how to do this, right? This one is very important part, right? So for that, what you can do, you can just simply call a function def player player decision. You can just write down this one as player decision, right? And inside this player decision, we ask some sort of different inputs. And we know that we have 4 different inputs. So instead of calling or like creating a individual input function to just pick the input value from the user, what I'll do, I'll just simply run the for loop over the X. And we know that, let's just run this first, right? It's like the player decision. And we have 4 different columns now. So we are getting 4 different columns for each of the values, right? Okay. Now, candidate, we have already created the list or like the values of individual classes. So instead of printing the I, what I'll just do, I'll just simply call the value or like pick the value of the outlook, temperature, humidity, and the wind as well, right? So now let's just use the same classes that we have just used, like this one, outlook classes, temperature classes, humidity classes, and the wind classes. Okay, just quickly copy this. Okay. Now go to this function and paste it here, right? What we want, we don't want this print, right? We just want the wind class, okay, humidity class, and keep it in a sequence, right? The temperature class, and the final one is the outlook class, right? Like this, okay? And let me just write this as all classes. So we are having 4 different classes: outlook class, followed by temperature class. The third one is humidity class. And let me convert this to list, right? And the fourth one is like the wind class, right? Now we are running the for loop, but we'll not directly run the for loop. What I'll do, I'll just simply use the enumerate function. And I know that enumerate try to create index and the values as well. So the first value that we'll get is the index, and the second value that we'll get is the value. Let me just show this first, how exactly this is performing, right? Index and the value. If you just run this now, you'll get, okay, outlook is at 0 index, temperature is at 1 index, humidity is at 2 index, and wind is at 3 index. Why we are like calling index here? Because at the 0 index, we also know that inside this all classes, we are having this outlook classes. At 1 index, we have this temperature classes. And at humidity, we have this humidity classes, and then followed by the wind. Because we want to create a dynamic method, right? So that user no need to like, or like the coder no need to write the each value individually. So instead of printing this now, let's just store the data inside on inside the answer variable, and you will use the input function, and you can just say enter value for index, like enter value for value. We know that this value is the column value. It's like outlook, temperature, humidity, and so on. So you can just write this enter value for this one. Now the first value is like the outlook, so the message will become like this: enter value for outlook. And how user identify the different types of outlook? So we have the different types of outlook now. So let's just write this inside the f string. And because we are getting the index value now, so user can simply call this index value, and we have all the classes. So it will try to go to the outlook classes. If the index is 0, it will give the all values of this index of this Outlook classes. And that is the reason we are just subscripting this. It's like this. Go to all classes. If the index value is 0, now just go to Outlook classes and print out all the Outlook classes and show the something like this. Let me just run this. It will give you the values like this. Enter value of Outlook. Now we know that we are only getting the like Outlook values overcast, rain and sunny, some sort of like this, right? So instead of running this, let's just stop this loop. Now we know that user can only select the value as overcast, rain and sunny. But the ML model need to work in different way. It is like if user is selecting as rain, so it should be 1. If the user is selecting sunny, it should be 2. If the user is selecting overcast, it should be 1. Guys, everyone is familiar with that, na? Instead of calling this Outlook like in a textual format, overcast, rain and sunny, what we'll do, we have to convert this value inside their index position, right? So we have to build some another sort of technique for that, so that that dynamic function can easily be converted into their index value. Now how to do this? Okay, just understand this is again the dynamic concept, right? Pick any of this for reference and let's just print it here. Now we know that overcast is represented as 0, rain is as 1 and sunny is as 2, right? So what I'll do, I'll just call the range function, and range function starts with 0, and let's just run with the help of this Outlook classes, right? And we'll get the data set like this, or like the data as overcast, rain and sunny, and we are getting the range value as 0, 1, 2, 3. Now what I'll do, I'll just simply turn out this into the zip object. Zip object, we can simply convert the zip object to the dictionary object. Let me just convert this to dictionary. Now we are getting at the overcast value, we are getting the value of 0. At the rain, zip is like binding the two objects. If we are getting like, let me just show you, if we have a two objects like this, Aman, and the value is like 1, 2, 3, and Karan, the value is like 2, 3, 4. So we can bind the value. It's like the zip object, okay? You have to store the values in like this, where we can simply bind the object. Let me just run this, zip, and if you just zip this, and let me just convert this to dictionary, where you are binding the value. It's like, okay, and it should be in a this way. The zip object is like, you have to first give the text in left side and the values in the right side. Okay, now this one. So where the Karan will be zipped by the, is there any like the problem with the extra bracket? Let me just write this. So Karan will be zipped by the 1, 2, 3. Sorry, the Aman will be zipped by the 1, 2, 3, and the Karan will be zipped with the 2, 3, 4. So this is called the zip technique that you can use, right? And let me just comment this off. Now we will use this, right? Okay, so we are getting the values now, where user answer will be stored inside this one, but we don't want to store this one. We, instead of storing the values like overcast, rain and sunny, we have to store the values in a format of 0, 1 and 2, right? Now we know that whatever the user will pass, the user will pass values based on their textual data set. It's like overcast, rain and sunny, okay? So you have to understand one thing. The user, whatever the user will select here, all give, it should be in the title case or like in the capital case, okay? So let me just stop this and let's just make this as a capitalized one, right? Capitalize will try to capitalize the first character. Now whatever answer that we'll get, suppose the first answer that that the user is writing is the overcast. So now we need to use this technique to pick the value of overcast as 0 and to pick the value of rain as 1 and to pick the value of sunny as 2. Okay, we have to use this concept. So just copy this one, okay, and just write down here, and it is like the dictionary index. Let me write this as a dictionary index, and inside this dictionary index will not always use the Outlook class or like the Outlook class. It should be based on the dynamic, right? And we know that if the loop will run first time, so it will give you the index value as 0. So it will have to pick the index value of 0 by default. So instead of calling this, what you will do, you will use this one. Okay, instead of this Outlook class, use the all class and then followed by their index value, right? So instead of this, let me just change this to all classes of index. Now this is like some sort of dictionary index, and we know that if the user is giving the overcast value, we just need to calculate the value as 0, right? So we have this dictionary index, and the user will give the overcast, rain and sunny, whatever. So what we will do, we'll just simply use this dictionary index, and inside this dictionary index, we know that the key will be stored as the overcast value, right? And we have to pass this inside the key, and this will give you the value. And let me just write this as the value, and whatever the value that we are getting, we have to store all the values like user data. Okay, let me just create this empty list, like user data, whatever the value that we are getting, we have to convert, or like we have to append this value inside the user data. See, that is the reason you have to very good with the Python, so that you can do some experimentation part if it is required. So what we are doing, we are just simply appending the value part on this user data, right? If we are getting the user data perfectly, so you can just simply return out this user data. Okay, instead of returning this, we have this ML model now. So what I'll do, I'll just simply call the ML model to predict, right? And the predict model will generally take this data set, user data set, but it should be in a 2D frame now. So we'll just use the another list, right? And whatever the prediction that we are getting, it is in an array format. So we have to slice out those array, and let's just store this inside the final answer. Okay, whatever final answer that we are getting, and we know that if the answer is no, so you can just write this, if the final answer is 0, so user will not play the tennis. So you can just say inside the print function, player not play tennis, because the output, you have to use the like double operator to compare the answer, right? If the answer, if we are getting the 0 answer, so you player not play the tennis, so you can just say player will not play tennis, right? And if we are getting the answer as 1, okay, so player will play the tennis. You can just write down this thing. And if you want to use some emojis, so let's just use the emojis as like this X. Player will not play the tennis. Okay. And at this position, you can use this tennis racket. Okay, like this one. Player will play the tennis, right? Some sort of like this. Okay. So we have created this function. Now this player decision generally be based by this function, where we pick all the values, we'll append all the values, and we'll like particularly call our model to predict the answer. Now once we call our model, the answer is either 0 or like the 1. If we are getting the 0 answer, so the player will not play the tennis. If the player, if we are getting the 1 answer, so the player will play the tennis. Now let's just stop this, run this function again, and run this play decision again. Now you have to pass the value. Okay, let me just pick the rain. Okay, so the outlook condition is rain, right? Okay, what is the problem? X has 1 feature, but the decision classifier is expecting 4 features as input. Why we are getting the problem? Okay, let me just write. Okay, so the problem is this, Vidwan, right? We have applied the answer here. It's like final answer is equals to model.predict. So it should be like outside the loop, right? You are not allowed to use this inside the loop, right? This is the silly mistake, right? Let me just run this again. Okay, now let's just pick the enter value of outlook. So the outlook value is like the rain. Enter value of temperature, it's like the hot. Humidity is like the very high, and the wind is very strong. Okay, now if we just run this, it will say class, look at this, player will not play the tennis, right? And instead of this, if you want to throw some images now, if you want to show some images as well, you can do this. We have a module for that. Okay, let me just call that module import IPython. See, whatever thing that we are performing each day is a project day, right? So we are using this import Python to show the image, right? So let me just go to this Google tab and play tennis GIF. I'm using the play tennis GIF as an image, where I'm just giving this as a player can play the tennis, right? Like this one, some sort of, if this image is perfect, so I'll use this one. Let me just wait for the same. This one is not good. Let me use this one. Yeah, we can use this one, right? So just go to this, right click on this, click on the copy image address. Okay, now just click on your data like function, click here. You have to just simply pass the URL where the player will play the tennis. Just store that URL here. Okay, it should be in a GIF format, right? And now just use your IPython function. Inside the IPython, we have a display method. And inside this display method, we have one method that is called image, okay? Where you can simply use your URL. If you want to show this image, so guys, you have to again use the outer display function. The outer display function will try to like display the images as well. Guys, I hope everyone is getting my point. Can it just let me know, right? So we have used this if the if we are getting the answer as like player will play the tennis. See, we have used this like player will not play the tennis. Why we are getting the player will not play the tennis? It is like player will play the tennis, right? Okay. Now let's just do this for player will not play the tennis again, right? Something like this. It's like the player is an idle condition. Is there any image where player is not playing the tennis? Uh, Not play tennis. Let me just check. Is there any related image with this like not play tennis? Mm, no, you cannot use this one, right? What about the rest one? Mm. See, we don't have he does not play tennis. Yeah, yeah. Let me just write yeah. Let me just take a copy of this. Right, he does not play tennis. Well, it is not required, but just for fun purpose, now we are using this candidate, right? So I'm just using the URL. Okay, and the URL should be in an image format. Now let me first open the image, and it is not exactly showing in an image format, but I hope it should run, right? So the URL is something like this, and let me just copy the same code and let me just paste it here, right? Now let's just run this function again, candidate, right? Okay. Oh, before printing it directly, let's just use the additional print to keep some to keep some extra line spaces. Okay. So let me run this function again. Now this is the player decision. Suppose the outlook value is like the sunny one, SUNNY. The temperature is very cool. Okay. The humidity is normal. Okay. The wind is strong, and you will get your answer. And it say cannot embed the image format because due to the player will not play the tennis. So instead of this, that is the reason. I was expecting some sort of issue, right? That is the reason. Let me just change this to another image, right? Okay, okay. There is no requirement of using image right now. You can just simply eliminate this one. Instead of see, we have shown image here, no? So you can just call it simply, right? Okay, now let's just test this again. So guys, you can just play with this code as well, right? Let me just select the outlook value as overcast. Okay, the temperature is like hot, and the humidity is like normal. Okay, and the strong is weak. And you are getting the answer, right? Player will play tennis, and you are getting images as well, can it? I hope it's working, right? Can it? Are you getting my point? Now the image size is very high, so let's just change this to, we have the width and the height as well. Let me just write this width as 200 and height as 200, right? I hope it should work, right? And let me just pass the value again. So the outlook value is overcast, the temperature is hot, the humidity is normal, and the wind is peak. And we are getting answer here, right? Player will play tennis. Guys, it's working. And I hope everyone understand this project where we simply pick the data set, right? The data set was related to the whether the player will likely to play the tennis or not, and we use the problem to to solve the problem with the help of decision tree, where decision tree is generally based on the like decision node, root node, and the followed by the leaf node. Now if you want to print this kind of root node, leaf node, now you can do this, right? We have another module for that, and we have already built this function where we just need to pass the values, and it will just try to predict whether the player will play the tennis or not, right? Now the final code, let's just print the decision code, right? Decision tree kind of a structure. So you can just use this from Scikit-learn. Inside tree, you will get this option that is called plot tree. Okay, let me just run this. Yeah, plot tree. Inside the plot tree, now guys, this one is very easy. You just need to give your model, right? And you can use the plt.show, and you can just do increase the figure size as well. Plt.figure, go to this fixed size. I hope everyone is aware with that. And let me just quickly give the fixed size as 12 by 6 like this. And let me just run this. Okay. And we are getting some sort of the tree value like this one, where this one is like my root node, followed by this one is like we are not getting any arrow now, so this is like, yeah, we have that arrow, right? So let me just quickly increase the size as well. Instead of 6, let me just make this 10, and inside this one we have some sort of argument as well, so you can take a reference of this plot tree scalar, right? You'll get this documentation, or either you can use like any LLM model, chat GPT and all. And let me just show the class name as well, right? We know that we have two different class now. Okay, first let's just turn out then this fill to instead of false, to let's just make this as true, and you can just see the difference, right? Yes, we are getting some sort of values, right? Okay, perfect. Now let's just increase the length as well. Let me make it 25. I hope it worked. Perfect. Now let's just increase the size as well, make it 20. It's working very fine, right? You can just reduce the size. Instead of 20, you can make it 10. And now just go to this option and take another argument. It's like the impurity. Yeah, you can pick the impurity as well. If you want to make it rounded, just pick this argument and pass the true here. And let's just pick another argument. How to show the like class name as well. We have a class name now, or like the label as well. So just simply pick this one and go to this. Now we are getting, see, this red one is like the no, like no one, and the first one is like the yes one. So it's like yes and like the no, right? So what you can do, you can just simply give the first one as the no and the second one as the 0. So it's like class name is equals to no, and the second one is like the yes. So we are getting some sort of class label as like this. The player will not play the tennis, yes, it will play, or like they will play. So we are getting some sort of two row like root node followed by the decision node, and some sort of like a Gini index. You are getting the value candidate, the Gini index value, or like the Gini impurity value 0.46. We have like the samples. It able to classify the samples out of 14 data set. It picked the 11 samples, right? And all these values are like the class yes, yes, class yes, class no, and these are like the decision tree architecture that we can use using the plot tree structure, right? If you want to show the features as well, so you can we have that argument, I think, right? So you can use this feature names, and you can just simply give the feature names and then followed by the x dot columns, right? We have 4 different columns now, so you can give all these columns, right? And you know that it by default pick the outlook. Now we know that the outlook was the root node. I hope everyone is familiar with that, right? Outlook was the first root node now, so it picked the outlook as the first root node, and then followed by their Gini values. And whenever you are getting the Gini values as the 0, always make sure that belongs to the like the leaf class. It's like the leaf node. This is the root node, this one is the leaf node, and whenever you are getting any kind of arrows now, it's like the decision node. So this one is root node, leaf node, and then followed by the decision node, where it's checking with the wind value. Now the wind value converted with the 2 different values. The first one is humidity, and the second one is again with the humidity, right? And again you are getting the Gini impurity is like 0 is the leaf node, leaf node, leaf node, and then decision node, and these are the decision tree that generally build with the help of Gini impurity, or like the Gini index. Okay, guys, I hope everything is clear, right? We build the model as well. We have converted the textual data into numerical one. We have one function where we just simply run this function. We have to pass some values, like based on the values, outcast, like overcast, cool, high, and so on, based on outlook, temperature, humidity, and wind, and it will try to predict the value. You can play with this function, right? I have already shared this notebook with you, right? I'll just also upload the notebook over the GitHub as well, so that you can take a reference, right? Guys, just let me know, is there any doubt or question related to this? Candidate, are you like, is it like good to go? I hope everyone has understand this concept, how to pick the model, how to create the model for the decision tree, and how we have converted the textual data into the numerical one, how we call the model, what about the like model evaluation parameter with the help of accuracy, model score, precision, classification metrics, and we have also plotted the trees as well. I hope everything is clear, right? Guys, is there any question, or is there any doubt related to any of these candidates? Just right now in the message box area. Peksha, Preeti, the rest candidates, guys, are you with me? Are you getting the point, everyone? Anas and the rest candidate. So this is for the today, and let me just share the notebook with you again, right? And what I'll do, I'll just go to this file. Let me just download this, Okay. So meanwhile, you can take a reference of this notebook. This is the link. And I'll just simply go to this one, decision tree part 1. And let me just upload the file. If I want to delete this, I can delete this as well, right? So I have already downloaded the file, I think, right? Yes. So now just go to this choose file. I'll pick this one. Where is the decision tree ML part 1? This is the final one. And now we have completed our decision tree model as well, right? In the next class, we'll start with the next model, that is random forest. If you want to learn something more about the random forest, you can just go and Google, and we'll start random forest tomorrow. And then followed by some sort of different techniques, bagging and boosting technique. And then we'll start with the unsupervised machine learning, right? So this is from my side, candidate. Wish you all the best, and let's connect tomorrow. Okay. If is there any doubt, you can let me know in the message area, and otherwise I'll close the session. Guys, is that clear? I think it's good to go. Just anyone write down in the message area. Shall we close this session? Apeksha, Sarath, Rakesh, Anas. Okay, Taruna, got it.